Denbydale Amateur Radio Club and to our regular online meetings, the details of which you can find on the club website at ddars.net. The calendar is up there, so by all means, if you want to check a meeting, have a look at that. There's also a link on that website, if you haven't already done so, to join the club email list, and you'll then get our regular emails with updates on the meetings that are taking place. So that's on there. And the other addition that we've now got up on the website, if you hit the contact button on the Denbydale Amateur Radio Club website, you'll see not just the list of the club officers elected at the club AGM, but also all the individual members of the club with their first names and their call signs. So all those of you that tick that little box saying you're happy to have your data shared and shared with members, then that information of your club membership is up there. So if you're looking for someone, you might find them on that list and think, they're a member of the Denbydale Radio Club. So go and have a look when you get a chance. Tonight's meeting, I'm delighted to introduce John, W6NBC, over on the west coast of the US there. What grabbed my attention to John was an article that he got published in the ARRL magazine QST. I think it was the August edition, wasn't it, John? On a simple design for a 6-meter inverted delta loop antenna. And I think in this club here, we've had quite a lot of speakers on all different kinds of antennas, something we can all do. Bit of kit is some task, and very few people actually manage that. But one thing that is quite possible for all of us to play with is building antennas, particularly wire antennas or simple antennas with only little bits of metalwork involved in them. And the delight of 6 meters is that they call it the magic band for a good reason. So just in the same way that 10 meters has been open recently, and Tom in South Africa was telling us earlier, he was working someone in Europe today running 100 watts into a vertical antenna, making contact with him down in South Africa. 6 meters can come alive as well, and we can have the same joy on 6 meters as we do on 10 meters when 6 meters does come alive. So it's definitely an antenna worth building. And the other delight for all of us, John, unlike many of the ham locations in the US, is that the lovely British small garden very neatly will very neatly take a 6-meter delta loop antenna where a 160-meter antenna may struggle, or even a 3-element HF beam. So John, I'll leave you to introduce yourself and take over tonight's talk. So over to you.
All right there, Nick. Thank you very much. Well, you're not alone with this small garden, because I have a small flower garden too. It's just the room for one small flower. No, I live in a very small place myself, and fight the same sort of a problem. Okay, very well. And of course, although I am an American by birth, I spent a good many years in the UK, living near St. Albans in a small village there, and that's where I became a ham and continue to hold the British call sign M0GCK. Although in those years I was G5AJH as a reciprocal, but now I have a proper British call sign, and which I'll probably never use again, but what the heck, it's fond memory. All right, we're going to, and I've been a ham over going on 60 years now, and it's been a great pleasure to be such. It's been a great hobby, and some of my ham buddies are the longest lasting friends I've ever had. We're going to do a topic, and by the way, 6 meters didn't exist when I lived in England. 4 meters did, but I never got on 4 meters. And by the way, this antenna will do well on 4 meters as well. So let's go to share screen here. Whoops, we don't want that. And we'll get rid of that as well. and don't save, and come up here and pick up our PowerPoint here. All right. Get everything in place and that out of the way. Okay. 6-meter inverted hen delta skeleton slot antenna. It's got quite a few elements to it to say the whole thing, so it has a long title. But it is definitely a slot antenna, and it's based on a well-known slot antenna, which most people don't know is a slot, the hentenna. And we're going to see how that played a big part in the development of this one. And it's an improvement over the hentenna, which some of you may be aware of and may have even built one in the past. Here's the article as it appeared in the ARRL's journal, the QST, back in August of this year, and attracted quite a bit of attention. It's built out of half-inch, since we Americans have not gone to the metric system, or approximately 6-millimeter copper water pipe, which is commonly available stuff from the local hardware store or local ironmongers. And I guess you can see here, based on the design that Koji Sugihara did back in the 1980s with the hentenna. And we've definitely improved its performance with this design. You see just the top section of it here sitting in front of my house. It is the sort of culmination antenna of a now approximately 6-year-long 1916 to 1922 love affair I've had with slot antennas. Now, almost all hams have heard of slot antennas, but don't know too much about slot antennas. Most of our antennas that we have are not slot antennas, at least we don't know they are. And hence we don't know what a slot antenna is. That's what led me to do slot antennas. I wanted to disguise it, my 2-meter base station antenna, then put it in my direct broadcasting satellite dish here. This is the one on the back of my house. It's still there to this day and still in use. I wanted to put a 2-meter antenna on this antenna so that my neighbors didn't complain, because I live in a small caravan-like mobile home, and my neighbors would complain. It's because you're not supposed to have any antennas, although they perfectly allow these DBS dishes. Everybody's got one, as everybody has everywhere in the world now. So I thought, well, let's just cut a slot in the reflector of the dish, and nobody will even know it's there, as you can see here. And I wrote this book on slot antennas, which you can still purchase if you want a copy of the book from Amazon.com. Just go to Amazon.com and search for slot antennas for ham radio, and it'll come up. It's I forget, about £3 something. It's not a expensive book, and it's available and tell you about slot antennas, and starting with this one. But hams today still don't know much about slots. They still think about a slot antenna in this form: a great big sheet of metal with a narrow slot cut in it. And this is why it never became popular, because that's what hams think a slot antenna is: a big sheet of metal, which, if you try to translate that into a 40-meter antenna, for example, it's a great big sheet of metal. If you put it on top of a typical small bungalow, this is what it would look like. A great big thing that obviously wouldn't go on top of the average small home. But that's what hams think about slots, so they don't consider building one. Well, there are a lot of practical ham slots, including this one, which is a slot antenna. But I wanted to know a little bit more about slot antennas after I was very successful with building my first one in that satellite dish. So I decided to do a little experimentation. Here's me with my MFJ 259B, which has now been replaced by a better antenna analyzer, although the 259B is a good antenna analyzer. Doing some experimentation with some aluminum tape on cardboard. just experimenting with slots. I wanted to know better about how slot antennas work, since most hams don't know how slot antenna work. And I had to make some important discoveries, which led to this antenna you're going to hear about. First of all, the biggest discovery I made was, how does a slot antenna work? We don't have any idea. We have this idea of a big piece of metal with a slot cut in it. And immediately comes to mind, well, how in the heck does a hole in a piece of metal work as an antenna? That doesn't make sense. How does a hole transmit? Well, if you look at this picture, though, you'll understand it. Look in the middle. What is that antenna? Is that an antenna you understand? Is that an antenna you're familiar with? Well, of course it is. It's a folded dipole. Any one of you out there ever heard of a folded dipole? Well, of course you have. You've probably got one or two of them. And your TV antennas, probably a VHF, if you still use VHF antennas. We don't use them much anymore here in the US, probably don't in the UK anymore either, but a folded dipole. All hams know what a folded dipole is. Well, a slot antenna is just a folded dipole. Look at the bottom. There's a slot antenna at the bottom with a smaller ground plane, and it's just a piece of metal that surrounds an open space. That's a folded dipole. The only difference is the slot is parallel fed, where the folded dipole is typically series fed, or you break the folded dipole. You could do that to a slot, although it's not very practical to break the ground plane, although it could be done. But any of you ever build or have or own a cubical quad antenna? You know, a quad loop, a one wavelength quad loop, or with 2 or 3 elements? Well, all of you know that if you feed the quad at the bottom, it's horizontally polarized. If you feed the quad at the side, it's vertically polarized. The same is true for the folded dipole. If you feed a folded dipole at the bottom, it's horizontally polarized. If you feed the folded dipole at the end, it's vertically polarized. That's why the slot antenna is vertically polarized, because it's end fed across parallel. So there's no mystery to the slot antenna. It's just a folded dipole shunt fed, and that's why it's vertically polarized. If you try to go to the antenna handbooks, they try to explain it with a lot of mumbo jumbo called Babnett's principle. Don't look at the handbooks. They can't explain their way out of a shopping cart. You know, it's the antenna handbooks are all they're just bollocksed up. They don't know how a folded or a slot antenna works. That's why I'm happy to see that in the coming issue of the ARRL handbook, finally, my good buddy who's the author of, or the editor of the ARRL handbook, is finally going to put my article in the next issue of the handbook explaining how the slot works. Anyway, so the slot's just a folded dipole, but it's shunt fed. Anyway, to prove that, here's a slot antenna of the classical design, a metal plane with a hole cut in the middle of it. And it shows the currents here. This is a demonstration of the currents in a slot antenna, a classical slot. And you can see they're flowing around the hole, not in the hole. A hole can't sustain currents. So the hole is not doing the transmitting, or the slot itself is not doing the transmitting. It's the edge of the slot, around the slot, the folded dipole, you know. So that's how a slot works. It works just like a folded dipole, which it is. It's a folded dipole. This is what led me to the kind of skeleton, the kind of slot that works well, the kind that you can use on HF or VHF or UHF practically, instead of that great big piece of metal on top of your house. It's this antenna. The first place I ran into a practical skeleton slot was the hentenna. You'll find this throughout the internet. If you look on the internet and search, you'll find the hentenna in many articles, even down to 20 meters. You'll find hentennas, and here's what they look like. They're just usually verticals like this, so they're horizontally polarized, and they're typically shunt fed, as you can see the shunt feed there. This is what the two Japanese engineers that first introduced this back in 1982, this was their basic design of the thing, roughly a sixth of a wavelength wide and roughly a half a wavelength long. It's a one wavelength loop all the way around, and it's shunt fed at about a tenth of a wavelength. That's not cast in stone. That feed point can move. It does move depending upon the particular antenna, but that's simply a shunt fed skeleton slot. Why is it a skeleton slot? Because the ground plane is just a skeleton. It's just a wire around the edge of an open hole or a slot. Well, that's a folded dipole or a skeleton slot. That's the practical slot antenna. That's the antenna that makes a slot practical for ham radio. And this is what this little antenna that I'm going to show you is. It's a skeleton slot, not a classical slot. It's shaped differently than the antenna because, frankly, the antenna's shape is not the optimum shape for the skeleton slot. It's basically better as a delta shape than it is as a rectangle. Okay, the third discovery that I made, and this is an important discovery which most hams are completely unaware of. If you stand up in a radio club and you ask a question, what part of an antenna radiates the signal? What part of it? You know, the ends, the middle in between. What part of an antenna does the radiating? You'll get a lot of people scratching their heads. They don't know what part of an antenna radiates. Is it the end? Is it the middle? Is it all of the antenna? What parts? A lot of them will answer, well, it's the whole thing. Yeah, I guess the whole thing does radiate, but is one part doing more of the work than some other part of the antenna? The answer is yes, very definitely. Not all parts of any antenna radiates. Let me show you. If any of you are into antenna modeling, like EasyNet or 4NEC2 or any of the other modeling programs, I'm a big antenna modeler. I like EasyNet. I got started with it years ago, but I'm also do 4NEC2, which is the one I now recommend because EasyNet is kind of fading. But I like EasyNet. I still use it. Here's a very familiar antenna, which I'm sure many of you are quite familiar with, the infamous copper pipe J-pole, which is a very popular and probably the most home-built ham antenna in the world, a J-pole antenna. Good antenna, very good antenna. But here's a J-pole, and here in the middle of the picture here is a EasyNet model of the J-pole antenna. EasyNet has a nice feature called the current display. You can turn it on. It's the current display. It produces on your model some purple lines or some mauve-colored lines. And the lines tell you the strengths of the current throughout the model or throughout the antenna. And I've made them the same size, so you could imagine the currents in that J-pole, which used to sit on top of my house. It doesn't anymore. It's gone. I've replaced it with another antenna, but that's the one that used to be on top of my house, which my neighbors didn't like. Anyway, but you can see the currents in that antenna. You can tell the currents, two things about the current from that display. The strength of the current. The farther the purple line is away from the antenna, the stronger is the current. And you can also tell the phase of the current, the direction in which it's the strongest. And so you can see the phase by the direction it is away from the element. What do you see here now when you look at that with that model? You see that in the top of the antenna, there's only current in one direction along the top, and it's strongest in the middle, which you expect from a dipole. But in the bottom, you've got current in both of those sections, but they're in the opposite direction, but they're of equal amplitude. What happens when you have equal currents, but of equal amplitude currents in opposite direction? They cancel. There is no radiation from the bottom of a J-pole because the currents in the bottom of a J-pole are equal and opposing. There's current there, but they don't radiate because the radiation of one side blocks the radiation of the other side. This is just a piece of transmission line. This is the same reason An open transmission line does not radiate because the current in one side prevents the radiation from the other side. The currents flow and the current is transmitted down the transmission line, but there's no radiation from the transmission line because of equal and opposing currents. But in the top of the J-pole, there is no opposing current, therefore it radiates. Therefore, a J-pole is just an N-fed half-wave dipole. That's exactly, a J-pole radiates and performs exactly like a half-wavelength dipole. That's an N-fed transformer at the end that does not radiate that U section. Very important principle. You can analyze any antenna this way, and I do it all the time. Okay, this antenna, the inverted delta skeleton slot vertical, has 4 definite advantages over the antenna. It has a low radiation angle. Why does it have a low radiation angle? It's a vertical. It's a vertical antenna. And it acts just like a vertical. We all know that verticals have a low radiation angle. They're good for DX. So this antenna is great for DX, even sitting right on the ground. Put it right on the ground and it radiates at a low radiation angle. For a horizontal antenna to radiate well, it has to be up quite high. But this antenna, you can put it right on the ground and it radiates at a low angle. But because of the current canceling in it, it's horizontally polarized, just like the antenna that's vertical is horizontally polarized, because it's shunt fed as a slot antenna. It's horizontally polarized. Why is that good? It's good because noise that's bad usually in a vertical is gone. The vertical polarization of a vertical isn't present here. This is a vertical with horizontal polarization. Therefore, the noise is down by at least 3 dB in this antenna. Also, the top of this antenna is the only part of it that's radiating. That little piece at the top is the only part of this antenna that is radiating. Therefore, the radiation is higher off the ground. Therefore, less ground loss from this antenna. And the 4th benefit of this particular antenna is that it is a vertical with azimuth gain. For verticals, there is no azimuth gain. They're omnidirectional, aren't they? You put up a vertical with radials or with a ground plane under it, and it's omnidirectional, isn't it? But this is a vertical that has azimuth gain. It has up to 6 or 7 dB directional gain off of this antenna sitting on the ground, one vertical. These are some significant advantages that you want to take advantage of. This is an excellent performing little antenna. You can see here's the easy neck current display of this antenna that shows you all of these things. You can see the currents in the bottom section of this antenna. Because they're equal and opposite, those vertical sections don't radiate, especially at the bottom. They do a little radiating at the top because they're getting a bit farther apart. But at the top, there's no opposing currents. So it's the top of this antenna that does all the radiating. And what's the polarization? Horizontal. This is a vertical with horizontal polarization, and yet it has low angle radiation because it's a vertical. Performance. Here's the radiation pattern. Look at it, low angle radiation. Put it at 1 foot above ground, and it's still radiating only at about 30 degrees. Put it at 10 feet above ground, and it's down about 15 degrees radiation angle. Excellent for DX antenna. There's the bandwidth of it. It's reasonably narrow, although not too bad. It's got a good bandwidth of about half a megahertz. You're going to have to do a little bit of tuning to it if you want to move it in the band, but a megahertz is not a bad bandwidth. It's a reasonably good bandwidth. I can't give you the whole band on 6 meters, but it's reasonable bandwidth. But here's the gain. Look at that gain, up to 7 dB if you put it at 10 feet off the ground, and certainly 5 dB of gain dBi of gain if you put it right at ground level. That's pretty impressive. If you wanted to get 5 dB of gain with verticals, you'd have to have 2 or 3 of them in a phased array to do that. But you can do this with one single antenna. Broadside, by the way, to the antenna. The antenna would be sitting right along the center horizontal line in this picture. So let's build one. Here's what it looks like. There's a pictorial of it on the left. It's approximately 9 feet tall. Approximately 9 feet tall, made out of 2 10-foot sections of 1/2 inch or 6 millimeter, roughly 6 millimeter copper water pipe, common copper water pipe, slightly bent at 2 feet to make a parallel section at the bottom, which is the tuning and matching section. 2 little sliders slide along it, one for tuning and one for matching. And it's held up by PVC, a PVC mast of inch and 1.5 mast. It can be any size you like, but I just used 1.5 because it's quite convenient, common size. And a T, an 1.5 T with a couple of side arms on it and with holes in them, which hold it up. And it sits in a ground pipe, also a PVC pipe, I think 2.5 inch or 2-inch PVC pipe in the ground. It's about a 2-foot piece of 2-inch PVC pipe, just buried in the soil. No concrete, doesn't need any concrete. Just I used a water drill and just bored a hole in the soil and put a 2-inch piece of PVC in the ground, and it holds it up very, very well. That's about a 5-foot support, and it holds that antenna up very nicely for 6 meters. You could do a 4-meter version, would be even lighter than this, would work quite well. I think you could go to 10 meters on this design. It would be a good bit taller. You'd probably use a little huskier pipe, both PVC and copper, but you could certainly do this, I think, in 10 meters as well. You also see the balun at the bottom, which is 6 turns of coax just wrapped around the same pipe and through some holes in the PVC pipe to hold it in place with some tie wraps. Very simple design, very easy to build, and so easy to do. There's nothing special about any of these dimensions. I think you can pretty much figure them out pretty much for yourself. It's about 3 feet wide at the top, and it's folded in there at about 2 feet up so that there's a parallel section for adjustment, and it just tapers out there to the top. So if you don't have these exact dimensions, you don't have to have the exact dimensions. They work pretty much anything approximately like this. How do you bend the tubing? Well, that's easy enough. It's rigid tubing is pretty hard to bend. I simply took a pair of pliers. I used the vice grip pliers, which have a lot of leverage to them. They have that geared sort of a mechanism, so they'll exert a lot of pressure. And I took a pair of vice grip pliers and set them so they would crush the tubing about halfway. And at 2 feet up the pipe, I crushed the tubing about halfway. Once you crush it about halfway, it'll bend very easily. And 2 feet from the bottom, I crushed the pipe, and then they will bend in quite nicely, as you can see here. The top is very simple. In an ordinary vise, I just flattened the ends, about 1.5 inches of the ends, and then hammered the ends flat on the same vise, and drilled some holes through the end for some 1/4-inch bolts or some whatever the metric equivalent of 6 millimeter bolts, I think they are, and some stainless bolts and nuts to hold them together. Easy enough to do. The little sliders that slide up and down that 2-foot section, here's the dimensions of them, but again, they're not critical. One of them is made out of aluminum and is held and has two little clamps on it. These are the little kind of clamps you can buy to hold the copper pipe which you can buy at a local hardware store. They're just the little clamps that you buy at the local hardware store to clamp down a 6mm or 1/2-inch copper pipe for plumbing purposes. And I use those clamps. I recommend you buy the copper ones, all copper ones. And one of the little bars is of some insulating material. I used a piece of some PC board with the copper taken off of it, and the other one is just an aluminum bar. I used 1/2-inch wide, but you can make it any width you want. They make those sliding bars. And here you can see the adjustment section. The one that's used for frequency adjustment is the aluminum one with the little clamps on the back to hold that it can slide on, and the other one is the one made with the insulating material, which also serves as the feed point. By moving the feed point, you adjust the SWR, because somewhere from the bottom of the antenna and up as you move that bar, the impedance of the feed point changes until you find the perfect 50 ohm point by just moving that bar up and down until you find it. It's an easy adjustment, very easy adjustment. By moving the aluminum bar, you change the total length of the loop until you get the resonant frequency you want. It's an easy adjustment that you can do easily with any antenna analyzer hooked up to the coax. And you see the balun at the bottom, which is 6 turns of ordinary coax. That's in a little balun form that I printed on my 3D printer, although you can easily do the same by just drilling some holes through the mast and winding 6 turns of coax between the 2 holes. Or if you like, send me an email and I'll send you the printer form if you have a 3D printer and would like to print one of those balun forms. So that's the inverted delta skeleton slot vertical. It has a low radiation angle, which is because it's still a vertical, and yet it's horizontally polarized, which almost no verticals are. It has elevated radiation because it radiates from the top, and it has azimuth gain. It has pretty much all the characteristics you want for an antenna, and you can mount it right at the ground. It's a smaller cousin of a bigger antenna that I use the same principle for, the all-band double inverted delta skeleton slot, which uses 2 of these inverted deltas in a wire version mounted at 90 degrees, fed with an auto tuner at the base, and works excellently on all HF bands, fed with an auto tuner, which is underneath that plastic tub there at the bottom, sitting on that little table at the bottom. You have to use an auto tuner at the base. You can't feed this antenna from your shack through coax. It won't work. You have to use a remote auto tuner. But this is an excellent antenna. It's an all-band HF antenna, which by using 2 of them in quadrature and a switching relay box, you can turn the gain 90 degrees remotely. So this is just another version. This was the version that led to the 6-meter one. And that's the little antenna. It's quite a winner. It's a good antenna. I find it quite effective, and quite a number of them have been built. Quite a winner for the for FT8. And this is my little doggy Lolly. No, she doesn't have a German call sign. She's not D0GGY. You can reach me here anytime you want at jportunaol.com or at my website, W6NBC. Take a snap with your camera of the Q code there, and that'll take you right to me. And that's it.
Brilliant. Thank you very much, John. That was really interesting. And I grabbed, just as you were finishing there and you were talking about it, I grabbed the design for an antenna. I'll raise it with you in a bit. But right, who would like to go first with a question or comment? Yeah, John, JMB. You're on mute, John. Need to unmute. Still on mute, John. We still can't hear you, John. You're still muted. Are you on a computer or another device? If you're on a
we should be
computer,
there now.
oh, there you go. That's it.
Yeah,
Got it.
I saved the screen with the picture of the aerial, and I was trying to unmute on the picture of the screen.
There you are.
Okay. Yeah, John, thank you very much. Couple of very simple queries. When you cite American sizes, half-inch pipe is half-inch bore?
Half-inch pipe is half-inch OD, outside diameter.
Oh, outside diameter.
Yes.
Yeah, okay. And the PVC used is what, Schedule 40?
Schedule 40, yes. Schedule
Yeah,
40.
which we don't have here.
Well, it's
very difficult to get thick wall tubing. Okay, that's fine. That was my query.
well, the PVC is unimportant. You just use something sufficient to hold it up. It's
Yeah. It looks so nice and easy.
Oh, it's a very easy antenna to build.
Yeah, I'll think about scaling it for 4 meters.
Yeah, if you do that, please send me pictures of it and your results for 4, because we don't have 4 meters here in the U.S., so I've had no reason to build one.
Okay, thank you very much.
My pleasure.
Thank you, John. Anyone else with a question or comment to John? Yeah, Roger.
Yeah, thanks, John. Really interesting that, and like you say, very simple. I presume that you say a half-inch pipe, but it's not critical, is it? 10 mil, 15 mil bore would be quite sufficient. It's just enough copper, really.
Oh, the copper was just for physical strength, and half-inch common water pipe over here is fine. You could use 3/4 or whatever, or 15 millimeter or whatever. It would be fine. Didn't make any difference.
Yeah, that's what I think. Because you've looked at have you soldered the bottom end? You've used some little couplings and soldered it.
Yes, there soldered elbows at the bottom.
Yeah, that looks really simple. Thank you very much. Thank you.
Sure. If you can get a hold of the copy of the August issue of QST somewhere, that's downloadable off the ARRL website. But
Thank you.
Everyone, I'll make available a copy of it. I'll put a link to it in the next email I send out. And if anyone wants to get one personally, just drop me an email at g4iwo@btinternet.com, and I'll send you a copy of the QST article that John had published in the August QST magazine.
there's absolutely nothing critical about any of the dimensions of this. Just make the top about 3 feet wide and the bottom about 3 inches wide, and give yourself about 2 feet in the straight section, and make yourself a couple of sliders that go up and down it. And the top one insulated for the feed point, and the bottom one metallic for the changing the length for the frequency, and you got it. It's an easy build and easy to figure out.
Yes. Anyone with a question? Anyone waving at me there? Wants a question?
Thanks.
Yes, go on, Keith.
Yeah, it's not really a question. It's great design. I'm fortunate. I've got a plumber here at the moment sorting out my utility room, so I shall be raiding his van tomorrow, I think.
Raiding the plumber's van.
Absolutely.
Yes, Phil.
John, what's your best DX you've worked on it so far?
Well, I tend to, my current interests are FT8. So with FT8, you work everywhere in the world. So you name it, it's everywhere everywhere. I don't do much sideband work these days.
Okay, thanks.
I like the digital modes, but other people have used it. I know the first guy that ever built one of these here locally and got on the air and immediately worked Spain on it. So I guess it works.
Yeah, very good.
Yeah, Phil, what I would say to you, and John, your comment on this, but there's absolutely no reason why you couldn't make it out of wire and suspend it from the top of one of the fishing poles. And,
Absolutely not.
And just have the design pegged out with some support at the bottom to pull it out at the bottom and pull it back in again. But that's going to work just as well, isn't it, John?
You can make this antenna on a wire quite easily and use some fiberglass spreaders at the top or something at the top to, and you can make two of them in quadrature if you like, and use a relay box to switch them to turn the gain 90 degrees. That's what my bigger one on HF does. And the bigger one on HF, which is a 25-foot tall one, held up by an aluminum telescopic mast with 4 half-inch fiberglass spreaders at the top, all built out of 14 gauge wire, AWG wire, on an auto tuner at the base. Can be done with the same design. You don't have to use an auto tuner. I just do that simply because it allows automatic tuning anywhere across the HF spectrum. But it can be certainly done by this same parallel tuning base at the bottom with a couple of sliders for tuning adjustment.
Oh, have you got details of that on your website, John? Of the HF?
Yeah, if you look on my website, this is pretty well covered.
Good, thanks.
A question, John, from Ken G4VZV. What is the total length of it? All of it? Is it a full wavelength?
Yes. The total length, it's a full wavelength loop, just like a folded dipole is a full wavelength around, or an antenna is a full wavelength around, or a cubical quad is a full wavelength around.
Yeah, okay. So how do you get the multiband coverage? Is it just by moving the slider up and down to get?
No, multiband coverage on the big antenna is done by using a remote auto tuner at the base.
Right. So when you are tuning using the slider, what are you doing there then? Just getting it to the nearest, as near to zero as you can, SWR, and then using your auto tuner?
No. I don't use both at the same time. The sliders are only on a monoband version of this antenna.
That's okay. That's cleared up what I wanted to know, really.
Yes.
Because I thought, what are you using? Which one or both to get the multiband coverage?
Now the multiband coverage, when I do the multiband coverage and I use an auto tuner, the length of the delta is not anything in particular. It can be any size. I've had people build them as much as 60 feet high. I've had people build them as low as 25 feet high. In fact, mine is a 25-footer, and it works very well right down to 80 meters.
Yeah. Have you phased and built 2 of them? I just wonder whether you've phased them, or if you've gone this far to make what you've made, have you then decided, well, I could phase 2 of them and get it really directional?
You could. I haven't, but I don't have enough real estate to phase 2 of them on anything but about anything much above about 15 meters.
Okay. Okay. Yeah. When you first started to describe it, I thought you were almost not copying, but the same attributes as a Cushcraft end-fed vertical antenna. That's what it looked like, half-wave end-fed at first. There was one other thing I was going to ask you. Have you got the measurements then for an HF one that would work on 20 meters?
Well, if you're going to build, if you're talking about a monobander.
Well, I'd like to look at a dual bander, or more than a dual bander.
Well, the only thing I've ever done on HF is a non-resonant version, which is a 25-footer which was a 25 footer fed with the auto tuner. But I did a little investigation on that antenna for HF as a mono bender, and I found that the best size to build the antenna, if you're going to make it a mono bender, is to make it a quarter wavelength high, physically a quarter wavelength high. So if you're going to go for what, 20 meters, what's a quarter wavelength, 32 feet? I would recommend a 32-foot high delta for 20 meters.
Right.
Ken, I'll send you a design that I've built, and that is a mono loop quad that will operate on 7 HF bands.
Oh,
so
sure.
you start with I used a 12-meter pole, and then you've got the delta loop, so that the top, my 2 fingers at the top are at the top of the pole, and then you've got 4 5-meter length wires. So each of the pieces going down, that's 5 meters, 5 meters going across. So 4 pieces of 5 meters, and then fed at the bottom of it with a 300 ohm feeder, and then put your 300 ohm feeder, take that across to your ATU, and the bottom is about 4 meters off the ground, and that you get radiating very well and resonant on 7 bands. And I've used 26 gauge wire for less than 500 watts, which is 400 is our legal maximum in this country. 26 gauge wire is fine.
The delta loop that I had up before the cobweb was a non-resonant type of delta loop. What I was looking at was the easiness of building this antenna against something like a 3-sided upside down triangle, which would be a lot easier, and feeding it at the bottom of the inverted triangle with a 4-to-1 balun. And because mine was non-resonant and was actually resonant around about 18 meters or 7, I think it was 18 meters, it covered 3 bands without any problem.
Oh, there's lots of wonderful combinations of things.
Yeah, that's right. Yeah.
Yeah,
Anyway.
John, Ken here, who's talking to you about this, is our delta loop specialist really on VHF. So, Ken, your favourite antenna is that delta loop beam that you've been using on 2 meters.
Sure.
And of course, there's no reason why you couldn't use. I mean, we're going back, as you said yourself, John. You're going back to the old days of the cubical quad, really, but just putting it on one side and slightly changing the shape of it.
Anyway.
So, John, I've got a question to you. So, changing the shape from the normal quad shape and squeezing the shape as you've done in your antenna there, you think that makes a difference to the angle of radiation from that antenna, improves the angle of radiation for DX working?
Yes, it does, because it's still acting much like a vertical. And if you look at the elevation radiation pattern as you come in from a square to more of a vertical, the elevation radiation pattern does come down, definitely.
And so the improvement your antenna gives, which I was intrigued with, is effectively the directivity that's available inside it.
Yes, definitely has.
I mean, we've, as you say, unless you built a phased array of verticals, you've got no directivity really to speak of. Whatever you try and play with radials, it doesn't make an awful lot of difference.
No.
The radiation pattern is equal around the antenna, but
That's right.
But with your design, it's different, isn't it?
Yeah, this is it's got a lot to be said for the inverted delta.
Yeah. Okay,
Well, guys,
anyone else?
it's-
Yeah, go on. Sorry, John, I was interrupting. Go on.
It's been fun. So I
But just before you go, let's just check no one else has got a question or comment to put to you before we say good night.
Yeah, can I have a question?
Yes, go on, Jeff.
Yeah.
Jeff from Belgium. Yeah, go ahead.
Hello, John. Thank you very much. This is Jeff from NT from Belgium. I'm just wondering, I'm living on an apartment and 3 meters high is a little bit, not HOA friendly. If I would put the antenna horizontal on my balcony or from the window, would that work? It would, of course, become vertically polarized, but
yes, it would become vertically polarized, and most of the energy would go straight up.
okay. At an NVIS antenna then.
Yeah, yes, it would become NVIS.
So
No,
not a good idea.
No, it's not a good idea.
Okay. Yeah, well,
It needs to be vertical. It is a vertical.
okay. Thank you.
Yeah, thank you, Jeff. John, can I thank you on behalf of the club for coming along, introducing it? I would like to maybe bring you back in a few months' time, because I know
anytime. I like doing these. I like
and
making these presentations.
John, my guess is that various people in here are going to be inspired to make variations of your antenna, and I would be intrigued
and send them
to see
along.
how they get on.
I love feedback from people.
I think a number of us can have a play with this as an idea.
Yes.
Can we show our appreciation to John before he goes? Thanks very much, John. It was extremely good. Thank you.
Thank you. Yeah, great antenna.
So cheerio, lads. It's been great fun.
See you.
Yeah. Thank you, John.
Cheers,
We'll raise a pint of beer to you in the pub. Cheers, John.
And the virtual pub.
Thank you, John.
Yeah, lift a pint for me.